Okay, here's another path counting question where we have a 2x6 grid and we have to follow the lines on this grid, and we have to get from A to B, from corner to corner, and we're only allowed to move up in the north direction or to the right in the eastern direction to avoid scenic routes and endless loops. So following those guidelines, there's only going to be one way to get to any of these points on our grid, because we're only allowed to move up or to the right. And at each step along the way here, if we just consider these 2 points highlighted in yellow, since there's one path to get to each of those points, if we start from there now and focus on just rightward or upward motion, then we can see that to this point on our grid, there has to be 1 + 1 possible routes to get there. And we continue that logic, I guess, and process each and every time. And 1 + 2 continue to flow up to give us 3 at that point, and another 3 at this point. And then we get another Pascal triangle number here. Those 3 paths can continue to flow right and up to give us 6. And I think we'll just watch this unfold here. So here we are, 15 and 6 can flow together and coincide at that point to give us 21. 6 and 1 can continue flowing from those 2 points. All paths flow upward and to the right to give us 7, and the final pair of points. Remember, to those 2 points, there's 21 and 7 paths respectively, so they can continue to flow to the right and up, coincide at our finish line to give us 28 possible paths to get from A to B, following the ground rules of only moving up and to the right. Okay, here's our grid again, and instead of using Pascal's triangle method to count the paths from A to B, we're going to use some of our counting methods that we've learned to date. So here's one path traced out on our grid. And of course that involves a series of steps to the right and up. And if we follow the exact order that's sketched here, it looks like we're going to go to the right. Remember, that's the eastern direction 3 times, followed by a northern direction once, and then 3 more steps to the right in the eastern direction, followed by 1 more up, northward step. And what we actually create is a word of 8 letters. And if you're wondering how many ways to arrange 8 things, 8 factorial is the number of ways via the fundamental counting principle. And we have a little trick here that we have to also consider, is all those repeated e's. We have to remove the order. If we cycle through those 6 factorial ways, we can arrange those e's in every single arrangement of these letters, or the 2 factorial ways we could also rearrange the identical n's. So the division there gets rid of, or I guess takes in consideration the repeated letters that we have, of course, in this, I guess we'll call it a word. And we'll explore this in the next video, but of course that 8 divided by 6 factorial and 2 factorial happens to be identical to a pair of combinations here. And that combination, those combinations happen to be 8 choose 6 or 8 choose 2. You can type those into your calculator or attempt to, I guess, manage this factorial mess here, which isn't actually that bad. You might as well do that. Of course, feel free to type that into your calculator to get your answer of 28. But if we count down the top, 8 times 7 times 6, and I don't have to go all the way down to 1 because of course I see a 6 factorial on the bottom, and then I have a 2 times 1, which is that 2 factorial broken down, and then I can divide those 6 factorials and realize that I have 56 divided by 2, which is 28. So Pascal's method worked very efficiently here, but also considering the number of paths here as a rearrangement of 6 steps to the right and 2 steps up is another way to count this question, and we'll start to tie in combinations into these types of problems more in future videos.